Hi class, this is the third and final video on the Bohr model of the atom, and this video is really specifically intended to help you out with one of our homework questions from our Chapter 5 homework assignment. And here's the Chapter 5 assignment, and the question I'm talking about is this one, number 6. And this is actually a question which is straight out of our textbook, Universe. An imaginary atom has just 3 energy levels: 0, 1 electron volt, and 3 electron volts. Draw an energy level diagram for this atom, show all the possible transitions, and then for each transition determine the energy and wavelength of the photon that would be either emitted or absorbed. And then are any of these photons in the visible part of the spectrum? So I want to give you some direction on doing this problem. So it's kind of it's a make-believe atom, but we're going to treat it very similar to the hydrogen atom, and this I think will give us a lot of good practice in thinking about energy levels and using Einstein's equation. So this is what I would like to see in your solution to this problem. So here are the 3 energy levels, 0, 1, and 3. And just, this is very different than the hydrogen where you've got 0, 10.2, 12.1, and so on. But it's still a good problem to work through. So if these are your 3 energy levels, here are all your transitions. You can go from 0 to 1. You can go from 1 to 3. You can go directly from 0 to 3 and skip 1. You can go from 3 electron volts straight down to the ground state. You can go from 3 electron volts down to 1 electron volt. And then finally, you can go from 1 electron volt to 0 electron volts. In these 3 transitions, the electron is going from lower energy to higher energy. And so these are examples where the electron is absorbing a photon of just the right energy. These are examples, these 3, this one, and this one. These are examples where the electron is going from a higher state to a lower state. So this is where the electron is dropping in energy, and it releases that energy in the form of a photon. So the electron's actually emitting a photon. So these are absorbing a photon. These are emitting a photon. To calculate the energy of the photon that's either absorbed or emitted, that's as simple as calculating the difference between the corresponding energy levels. So from here to here, that's 1 electron volt. From here to here, that's 2. And from 0 to 3, that's the full 3 electron volts. And then you do a similar thing for these transitions. And then once you know what these photon energies are, then you go to Einstein's equation right here. And you plug those energies in here to figure out what the wavelengths are. So you can calculate what is the wavelength required, what's the wavelength of the photon required to bump this make-believe atom from its ground state, 0 electron volts, to its first excited state, 1 electron volt. And what about going from the first excited state to the second excited state? Well, then it needs a 2 electron volt photon. Well, use Einstein's equation to calculate those wavelengths. So obviously this and this, these are going to have the same photon energy. So it's going to be the same photon, same wavelength. It's just, in this case, it's being absorbed. In this case, it's being emitted. And this guy and this guy, these are going to have the same photon energy and wavelength. And then these two are going to have the same photon energy and wavelength. So that is how you do that problem. This is from our Chapter 5 homework assignment. It's this one, number 6. And then keep in mind that when you get these wavelengths, put them into nanometers, and remember that visible light is from approximately 400 nanometers to 700 nanometers. So if the wavelength turns out to be more than 700, then it's infrared. If it turns out to be less than 400, then it's ultraviolet. If it's between 400 and 700, then it's in the visible part of the spectrum. So then for those 3 photon energies and wavelengths, you can determine if any of them are in the visible part of the spectrum.